This is Linux in Laws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever else fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy, Mum? Thus, the content is not suitable for consumption in the workplace, especially when played back on a speaker in an open plan office or similar environments. Any minors under the age of 35 or any pets, including fluffy little killer bunnies, your trusted guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs. Welcome to Linux in Laws, Season 1, Episode 91. Martin, how are things?
Yeah, things are good. Sun shining. It's warmer than in the rest of Europe. So what more do you want?
Excellent.
No fires also, which is good.
Yeah. Of course, we're recording this December 2027, I think. If memory serves. Martin has just reinvigorated his time-traveling device.
Yes, it's damn handy that.
Exactly, but today is not about time-travel devices, funny enough, but rather about something called software quality.
Before we do that,
yes.
How are you?
Can't complain, Martin. Can't complain.
Okay.
I'm not time-traveling, so all is good. So I'm not creating.
Depends how you look at it. It could be good and bad, right?
So
many advantages.
That I create any conundrums by changing the past and so forth are pretty minimal because, as I said, I'm traveling. Or changing the future or something like that, which always carries the risk of doing so if you time travel.
Yeah, I'm sure. If you do have these encountered these risks, do send some feedback. That'd be interesting to hear.
But anyway, okay, back to the topic we had, namely software quality, Martin. So, what exactly is software quality?
Well, software quality. It's a good question. It's a measure of how well it works, I guess.
Excellent.
Or not, as the case may
so
be.
you write a piece of software, you do the you do the documentation, you probably do some testing, and then you find out this shit doesn't work.
Well, it's usually afterwards is when the users complain, right?
Okay. So software quality, in contrast, I reckon to the popular impression, is actually rather a kind of ongoing process, I suppose.
Yeah, well, this is why we have releases, right? Releases are not just for features, but also for releases. Releases are more for bug fixes. I guess patches are more. Releases are more for features. Bug fixes are more done in patches, right?
Yeah, so software quality, I reckon, is a process framework, so to speak, that consists of multiple components, and software testing, I suppose, is just one of them. So, for example, how you measure quality of code as static code analysis is I reckon also a metric that you can use in order to assess software quality. How well the documentation is written, how well you actually do the software testing, how you scope a project, and all the rest of it.
Yeah, I guess in short, you can say that the quality is as good as the testing framework or the defined test, right? If you if you release something and do zero tests, then you can imagine that there will be certain things not right with it. And the more testing you do, or the more tests you define, more importantly, the more you can make sure that the product does what it's meant to do.
Yeah, and testing, of course, is not in that case defined to just code, but rather also, as I said, to the documentation and to any project, any aspect of the product that you're actually producing. So I reckon usability, for example, as in how well a user can interact with the software, is also part of the overall software quality assessment process, but also how well the documentation is written, how deeply actually have you tested the software and all the rest of it, how well the overall project is documented. These are all parts of software, of the overall software quality, I reckon, of a project. As in, I'm almost tempted to say it's just not software quality; it's rather just project quality, and that encompasses the software, the process, the product, and all the rest of it, I suppose.
No, for sure. I'd say those other aspects are also very important. Well, we kind of set the scene, right? About
yes. So going over now to maybe software testing. Or should we discuss something else first?
Well, I mean, testing is one aspect, right? It's okay. Maybe let's talk about the whole process from beginning to end, perhaps in short.
Okay, let's use the popular example of an money laundering application. I.e., you take some money and you want to launder it. Say 30 degrees, kind of cold, with kind of drying afterwards, as in tumbling. So no,
not traditionally done with software, though, is it? There are other ways, I believe.
No, I mean jokes aside. Imagine an application that takes a couple of not bitcoins don't need to be laundered, I suppose, but takes a wallet in terms of an existing currency and kind of does the laundering automatically. Let's put it this way, using an elaborate framework of banks, clearinghouse, and all the rest of it. So you start actually with, I reckon the young kids would start, the agile kids would start this actually with defining a couple of use cases. As in, a user wants to launder a certain amount of currency. And then the input would be the currency, maybe also the way that it should be laundered, for example, not using one or two specific banks, but rather alternatives. And the output then would be assets that the money has been turned into.
Okay.
Like bitcoins, like gold, what have you.
Handy app. Have you got a name for it yet?
Yeah. What about ML?
Is this your pet project?
Can't you talk about this? Okay, I reckon with that you would also start, because agile normally means that you don't add the software testing at the very end, but you do this in what the kids, I reckon, call test-driven development, i.e. you program the test cases alongside your code block. But before we even go there, we have just defined use cases. So we kind of define a testing strategy, I suppose.
In fact, you write the test before the code, in fact.
Exactly. So, but first of all, we define an overall test strategy, I suppose, where the test-driven development is at the very core. And as Martin has just pointed out, test-driven development, that means basically you write the test case before you actually write the code. This development goes back, I think, to the 80s or 70s. Links maybe in the show notes. A guy called Kent Beck actually did the first book on this, if I'm completely mistaken, or one of the first books. Maybe I'm wrong. Okay, now we have defined a couple of user stories. We have defined a couple of user stories. Let's put it this way. So what we do then, we also have defined a little bit of our testing strategy, but we still need many more things to do.
Yep. Well, it's the whole, let's say, the development and release pipeline, right? Because we can't just build some software and then what, right? It has to be, it has to run somewhere, it has to be released somewhere, it has to be, obviously before it gets released, it typically gets tested, but defining from writing the stuff to actually running it in production scenario. I mean,
it's happen. Yeah. That's absolutely spot on, and I reckon these days a central core or a central aspect rather of the whole thing is actually how you want to use this. So let's imagine for the purpose of this example that this is actually a cloud-based service that is offered on the darknet. Okay. So that means that you have, I reckon these days that would boil down to continuous integration and continuous deployment.
Okay, so maybe you need to expand on that a bit more. Why do we need this continuous deployment?
Because as soon as you develop a new feature, you do the quality assurance on this, and then you release it. Because you want to, yeah?
Yeah, it's a little bit more than that because, lots of the modern software development happens not so much in let's define everything at the start. It's more like let's get a product out with minimal features and then start adding stuff. But at least we have a product out there, and we can add things as we get feedback from users as well. So that's it. So that's why you need this continuous, release pipeline.
Yes, what Martin has just described is basically the agile journey from something called a minimal viable project, a product as an MVP, to something which is much more feature complete and much more elaborate. But essentially what you do is you start out with a kind of minimalistic implementation of a software base. What that does probably just one thing very redundantly in terms of it takes a certain amount of cash and just launders it, but does it only with one bank and produces only gold or something like this. And then you would expand that code base by also incorporating other outputs, other forms of output, like Bitcoin, like cars, like expensive watches, you name it.
Yep. Yeah, so in contrast, in the olden days, we used to have what's called waterfall development,
yes.
Right?
So Martin, because you're probably a little bit older, so why don't you explain what waterfall is?
Well, in a nutshell, it's really you take that whole process in stages. So first of all, you write down your requirements, then your requirements go into a design. Your design goes into implementation, and then your implementation goes into a testing phase. Finally gets released. So that's typically rather than just opposed to the MVP approach and just get something out there and add stuff as you go along, you define all your requirements at the start, and it takes therefore a lot longer as well to get something out, and it may not be the right product or anymore by the time it comes out, and or it may be already built by someone else, etc., etc.
Yeah, and of course, the advantage of doing a waterfall of doing a project in a waterfall fashion means that you probably only have one release per year, and getting a new feature into a release takes another year. So that's not exactly tied in with the
same as change request. Yes,
exactly. That's probably not tied in with the fast-moving pace of what is now known as the cloud or some other hipster deployment scenario. Because competition is always out there, right? So people wanna add features as they go along, and they don't want to wait for a year in terms of that feature to appear in the code base.
Very good.
Okay, so you've defined the scope for an MVP. You probably have started to do some initial design. Very important. At some stage, you probably want to think about the architecture in terms of how you want to deploy this on the darknet, what sort of cloud you want to use, and all the rest of it. And then what?
Well, you got to write stuff as well.
Yes,
or use some kind of GPT engineer stuff to do it for you. But
yes.
Yeah.
So you decide on implementation technology, like a particular programming language, like
Programming language, framework,
or Rust, whatever exactly framework,
libraries.
Yes, and then basically because you're using test-driven development, you essentially start writing tests that reflect initial use cases.
Yeah. Well, the tests come really before the design, really. Because you've defined your use case, so your use case is
yes.
Something goes in, this comes out, so you can define your tests along those lines.
Yes, we should probably actually also define the three different parts of the overall quality software testing sequence, which is unit test, integration test, and actually it's four. System test, as also known as end-to-end, and of course user acceptance. Martin, you wanna take us through them?
Yeah, sure. Okay, well, so your unit test is obviously if your code is made up of multiple pieces, services, whatever you want to call it. The smallest, let's say, thing you can test, whether it's a function or a library of functions, or that each of those could be considered a unit, and you test those in isolation. Let's take a simple example, right? You have a function that does a mean or something. Fine, you put something in, something comes out. Is that actually the desired result? Then you can put all those functions into a library. You could call that a unit, do a whole test suite for the whole library, and then the next one is really the where the units, let's say, interact with each other. So rather than testing your mean in isolation, it's like process X is relying on the mean function, and therefore it's putting in these values and does something else with it, so on. So is that in combination still working? Where were we?
You just described the initial stages of system integration.
Yes, yeah. And then, so that obviously system integration is also the external part. If we're using external APIs for banks or whatever, then we want to test that part as well. So everywhere where your piece of code is really interacting with, let's say, not the code itself, right? External bits to your code is your system integration testing. Yeah.
Yes, and the final part, I reckon, is user acceptance.
Yeah, this is where Chris sits behind his terminal and puts his 10 Bitcoin in, and some gold comes out.
And Martin, what hasn't been discussed at this point in time is a vital ingredient along this sequence. Well, praying is very important, because as you progress along that line, and I'm going to explain why that is in a minute. You're relying more and more on components that other people probably have written, because especially if you talk about libraries as in third-party components, you did not author that code base, but rather somebody else did.
Yep.
Now, you just can hope that the quality assurance of that external component has been done properly. And this is basically where praying comes in. So with the unit testing, you haven't written the code yourself, so you know how shitty or how good that is.
But you don't know until you test it.
Well, you still have control over it, so you can can refine the implementation, I suppose. But the more you rely on external components, and that's probably the ultimate case, is actually user acceptance, where somebody else tests that code or that product for you, the more the magic comes in terms of you lose control to a certain extent of what you can do and what you cannot do. Because normally user acceptance would mean the line of business, or we have a fund that project has a couple of ideas how that outcome should work.
Yeah.
So this is what I mean by use cases, in terms of what the kids call, I think, stories, if I'm completely mistaken, in a more agile context, where you and the example that I just gave initially when I described the MVP is probably the starting point for this. You want to launder one unit of currency into gold or something like that, and if then half of the money disappears because the whole thing doesn't work, that's not great.
Yeah.
And so
a fail.
Exactly. So before you would even start programming, you want to make sure that the MVP covers the most important stories or use cases, because otherwise the user acceptance test won't fly.
Yeah. And what usually happens is that your programmer or programmers don't think about all the cases that your users do. They have different interpretations, right, of what it should look like, and that's why testing is also important.
I reckon that goes back to the overall agile approach, because when Martin described the waterfall model, that was actually back in the olden days, like
it's not that long ago.
20, 15 years ago, where you had actually separate IT organizations, which were separated from the lines of business, and the lines of business had some vague idea of what a software product would do, or should do rather. Then they would write this down in an ideal case, and then IT would do something, and just about 2 years later, IT would ship something, and the LOB would come with linchpins and pitchforks and all the rest of it, kind of trying to crucify the IT, because it took way too long, as it was the case then, and the scope, because maybe of poor definition, because due to poor definition, or maybe due to poor implementation of the overall requirements, was also not great, because the LOB had something completely different in mind.
Yeah.
And that's exactly what you prevent to a certain extent with more agile approaches, where you have shorter implementation cycles. For example, Scrum says something, the ideal sprint, which is an implementation period in the Scrum methodology, is about a fortnight.
Yeah, 2 weeks.
Exactly. So you cannot kind of diverge that much within 2 weeks, because
at worst, you wasted 2 weeks of work, right?
Exactly. At the end of every sprint, basically, what you do is you sit down with the so-called product owner, which normally represents the business, and goes through the outcome of the sprint. As Martin just rightly observed, if this sprint didn't go according to plan, you have just waited 2 weeks, but the overall project is still somewhat on track.
Yep. Where were we again?
We were discussing the life cycle of a
project. Yes, the various testing phases.
Exactly.
Yeah. Yes, carry on.
So user acceptance is just almost upon us. Martin has, of course, or the programmers have used the Bible to a certain extent, or whatever religion they subscribe to, and never stop praying, hoping that at the end of the day, user acceptance testing will be a success.
Yeah, fair enough.
In an agile world, of course, user acceptance is normally quite, I wouldn't say small, but due to the overall involvement of the business as a line of business, user acceptance testing is, I reckon, based on the continuous development, I wouldn't say limited, but also somewhat interactive, because what you would normally do is, once you've completed a sprint, added a new feature, you would normally plan for a very short user acceptance phase at the very end of said sprint, or maybe just shortly afterwards, depending on how it's structured. So you wouldn't have that kind of couple of months long user acceptance phase that you would typically have with a waterfall model, where a line of business would take the overall code base and would test it inside out. Because with agile approaches, you do not have that Chinese wall between the business and the IT that implements the code base.
Yeah, that's fair.
So would it make sense? Yeah. So user acceptance has passed. Everybody's happy. So now what?
Well, then you come to release it.
And then you pray again, exactly.
Use. That's where the bugs happen. For all the tests that you haven't written.
I mean, normally you would ensure, due to communication between the business side and the implementation people, that you would have a sign off on the number on the scope of the use cases that you're about to test during the various sprint cycles prior before you even start. So if there's a use case missing, that shouldn't happen, because normally any stakeholder involved would review the story or use case document before even implementation starts, in terms of, do the use cases cover the functionality starting with the MVP and reaching right down to the very final product, that we anticipate, in terms of, are we complete with regards to the overall scope of the story of the stories or use cases versus the feature set that we're going to implement. So the chances that an important use case is missing is probably very slim in that case, because everybody has signed off on that testing document.
Yeah. Yes, but that doesn't mean that all the tests are actually been thought about, right? That's the...
No, I mean, especially as we all know, the old what's called, not Pareto rule. I can't remember the exact name of that rule, but about 20% of the overall effort of implementing a code base is done during the initial implementation phase, and about 80% is actually spent on something called ASM, application support and maintenance.
You mean bug fixing? Yeah.
Bug fixing, adding additional features, and all the rest of it.
Hmm.
I think it's called parental, but maybe I'm wrong.
Not sure.
Links, kids may or may not be in the show notes. Okay.
Uh-huh.
We have now released this overall product, somewhat feature complete, to the dark web. Have pointed all the relevant search engines on the dark web to that money laundering project, and now, despite initial projections, this project is really taking off. Everybody, right. World and dog are trying to launder money with it. Needless to say, that uptake wasn't anticipated by the business that funded the project. Never mind the IT who designed and implemented only a limited amount of scalability. But this code base now is this product is really now exploding in terms of popularity. So what we're going to do now? I mean, we have three options, right? We can stay the way it is. The code base can stay the way it is, meaning because we get a percentage of any money laundered, the business will only grow linearly, not exponentially, because we can only serve so many users.
Okay.
We can take the project down, meaning we don't get any percentage because the product isn't there anymore. Or we can try to scale up in terms of we have to modify the code base so that it can grow with the exponential take up in the marketplace.
Did we write it with scalability in mind in the first place?
This is actually a very good question.
Was that a user story or not? Very not. You
see, Martin, imagine if it wasn't, because the business was almost kind of halfway asleep because they didn't anticipate that pickup. So the IT didn't have it, or the implementing people didn't have it on the radar. So, but now we're in that conundrum, basically, that we have to do something about it.
Okay.
So we go back to the drawing board, and now we incorporate a much more scalable approach, I suppose. So that means revisiting the architecture, revisiting the design, and then, of course, changing the bits and pieces that need changing. But we also want to make sure, actually, that these enhanced scalability requirements find their way into the user stories.
Indeed.
So I reckon performance testing, which to a great part is how a code base reacts to scalability issues, I reckon would be at the very top of that list.
Yeah, that's true. If that was part of the original user stories, then you should have had a...
Which, of course, brings us nicely to something that we have completely kind of not defined until now, namely functional and non-functional testing.
Okay. Yes.
Care to elaborate?
Sure. Yeah, well, I mean, as the name says, functional testing. Testing the functionality. Does my average function actually calculate the mean? Yes or no? And non-functional is how many of these averages can we, let's say, calculate in a minute or a second or whatever. Right? That's could be a non-functional requirement. Say, I want to be able to launder 10 million bitcoins in 5 seconds for the population of China or something.
So functional testing...
ambitious, but
yeah. Functional testing, as Martin rightly explained, is anything that boils down to the original functionality of the MVP of the code base, in terms of, does it what it is supposed to do? In terms of, we have defined functionality, and does it do that? And any aspect outside this functional testing scope is actually called non-functional. So, as Martin already kind of touched upon, scalability. How resilient is the code base? I.e., if we pull the plug on a number of servers, will the software still work? Which, of course, happens quite frequently in something called the darknet. Or dark web.
Or the cloud as well, even.
Exactly. So servers disappear and appear and reappear all the time. So how well does the software cope with this? As in, will it continue to function? will it just do a half-baked job in terms of will it launder some money, or will it not launder any money at all, or will it just basically take a little bit of a dip, but it still works? And also, how well, for example, does the software detect that some part of its infrastructure is failing?
Yeah. Okay.
And
Well,
we already kind of touched on scalability, or, for example, how well the software kind of reacts to somebody. I reckon this is the gray zone, right? If somebody bombards it with crappy requests, as in just pumps it full with garbage, what happens? I reckon I think that part is part of functional testing, because if you pump it full of garbage, how does the software react to invalid entries?
Mm-hmm. And then, was there a story for this? Yes or no?
Exactly.
If not, then you bugger, don't you? Yeah.
But I reckon, especially if you're talking about resilient software, this is a very important part of testing. How easy can you break the software in terms of, if there's a malicious actor, say the beloved competition, that is also offering a money laundering service, you want to be careful that you anticipate the competition trying to send C4 your way in terms of let the software explode at the end of the day. So how well are you, or is the software prepared for handling these things? Which nicely leads us to the very interesting subject of security.
Well,
in terms of how
at some point we need to also address the open source angle.
Yes. we still have 4 hours, Martin, so no worries.
That's true. Okay.
No, I mean, that becomes more and more important if you're talking about applications that do face the World Wide Web in terms of the internet, i.e. are not running in an air-gapped environment without any outside interaction. No. If you're talking about a public-facing application using web servers, using middleware and so forth, you want to make sure that the attack surface, I'm going to explain what that is in a minute, is minimal. And the attack surface is actually something that anybody else can use to break the system. In terms of either break into the software, to crash it, as in have the software malfunction, or to simply take it down, or worse, enters the software and persuades the software, or tries to persuade the software to do something it wasn't supposed to do. Typical example in a Linux-based system, going back to the open source angle now, how easy can you elevate local user privileges in terms of you are in a shell, you're
in a shell.
Yes,
this is exactly bad. You don't want to.
And how
your application doesn't want to allow shell access.
I'm going back to the application in a minute, Martin. Okay. I'm just using a familiar example. So and quickly, how quickly can you escalate?
It's a bash script application.
Exactly. How quickly can you escalate that shell to root privileges? Going back to the anti-money laundering application. Sorry, not anti-money laundering, but money laundering application. So I'm getting confused myself now. Okay. Going back to the ML application.
This was a good application. Yeah, you put your money, nothing comes out.
Exactly. Imagine you have an administrator mode where you can actually control the flow of assets, can divert assets, and all the rest of it. Okay. So needless to say, this administrator mode of that money laundering application should be well guarded for obvious reasons, so that only a few selected individuals can actually use this administrative mode, because if that wasn't the case, Word and DAW could do anything that they want with the application, goes without saying. So, and the idea behind that minimal attack surface is actually to make sure that, never mind what you do with the application, that it withholds, that it stands strong with regards to any attempt to break into that application and to escalate to that privilege level.
I have a question. What about how do you build any anti-social engineering into there?
That's actually more, I reckon, a process issue. So
okay,
somebody,
fair enough.
I reckon. If you have, for example, if you have a helpline guarding this application, so that actually customers can phone in and say, "Look, I just lost €1 billion because that wasn't laundered properly." You want to make sure actually that that helpline is then guarded against any social engineering effort. Or maybe somebody wants to reset a password, the usual case essentially, for that money laundering application. Some of it can be built into the software. So, for example, two-factor authentication comes to mind, that people not just only have to enter a password, but also have to use a YubiKey or a fingerprint reader or something else in order to authenticate against the application. Again, raising the bar with regards to unauthorized access. But I reckon the rest is then down to process improvements on a function level beyond the implementation of the code base. So much for functional, non-functional testing, IT security, and minimizing your attack surface.
Yeah.
So should we talk about some tooling now before we close off the show?
Okay. Go ahead. What tooling would you like to talk about?
Well, we can touch upon continuous integration, continuous deployment, because I reckon this is what you see at the hyperscalers left, right, and center that offer similar services for continuous integration, continuous deployment.
What about test automation?
Yes. Normally, you would build this into your, say, Jenkins, into your pipeline in terms of, if, for example, Jenkins is a typical continuous integration tool where you simply have stages that gather all the source code from a version control system, that trigger builds. That build then passes an initial smoke test. A smoke test in that case simply means the software passes an initial test of use cases that determine, would it make sense to continue the quality assurance, or is the build so crappy that we won't bother to perform the rest of the tests? So assuming that the smoke test has passed, you would then execute your ordinary test harness, hopefully that has been complemented for the new features that you have implemented. You would, prior to the build, of course, you would probably take a look at the code coming from the source code repository in terms of doing static code analysis with a tool called, for example, such as SonarQube. SonarQube is able to take a look at the source code to detect so-called smells, i.e. portions of the source code that do not look like an immediate error, but have the potential to become one. Say, the strange use of pointers in C or C++ comes to mind, or the improper handling of variables in other programming languages. Normally, a good static code analyzer is able to identify these smells and to flag them. Needless to say, depending on your internal guidelines, that you can also convince a static code analyzer to ensure that you have used the proper coding schemes for your programming language of choice. Some languages prescribe proper coding aspects more than other. Python, for example, comes to mind. So if you don't indent properly in Python, you will have strange results, let's put it this way. Or other programming languages with curly braces, they are normally the compiler takes care of checking that your curly braces, for example, match and so forth.
Yeah.
Other than that, it basically boils down to your test harness in terms of how much you can automate with regards to testing and general QA, because essentially what you want to do is you want to have the human amount of quality assurance in terms of software testing down to a minimum. Because as we all know, humans are expensive, and normally you would automate as much as possible of the overall software testing effort before you even go near about releasing a build.
Yeah, fair enough.
So I only know a few actually test harness, open source test harness. I think there's something called GNU Test. Of course, every programming language offers rather, not any, but most programming languages offer some sort of testing framework. For example, there's something called PyTest in Python.
Yeah, there's PyTest for Python. There's
which is quite good,
like
actually.
for Java, and there's all sorts of stuff like that, right?
Yes.
So, yeah.
But I reckon that helps you more or less just with unit testing, right? because this is what you would typically use on a unit testing level.
Yeah, but then you could string them all together and
yes, indeed.
Yeah.
There are also kind of fuzzy test frameworks. As I said, links will be in the show notes.
Now,
unless there's something you want to discuss, something in particular at the moment, Martin?
Well, what we haven't kind of discussed is the most important point about open source and software quality, right?
If you put anything on GitHub, you want to make sure it compiles?
No, it's you worked for these kind of companies before.
You love me, Martin.
Now, the most common or one of the, let's say, good things about open source software is the fact that there are many people scrutinizing code or have the potential to scrutinize the code before it goes into various stages, pull requests, etc. People
Absolutely.
will, spend considerable time over before they are accepted, etc. So, so the important aspect of open source software is that it is available and anybody can find bugs and also fix them.
I mean, that's the reason why, for example, software defect reporting is an integral part of something called GitHub, or GitLab for that matter. As in Git-based large-scale code repositories, where you can simply then open an issue, to stick with the GitHub example, and then depending on your GitHub account and some other variables, that workflow behind the issue from the initial triaging right up to fixing is handled then by the project, including email communication and other tracking means.
Yeah.
Anything else before we head over to the boxes?
Good question. No, I think that's probably a pretty good high-level overview of this fun topic. And
people, in case we did forget anything, the feedback, email is feedback@linuxinlaws.eu.
Do we have feedback, actually? Do we have feedback?
We do, but there will be an upcoming episode where we
the
amount of feedback that we
amount
have
of
gathered.
Yes, the feedback episode. Sorry, yes.
Yes,
okay.
Exactly. So, shameless teaser. There will be an episode on the accumulated feedback very soon, in terms of before the year's over. But of course, we want to leave the year open when we do the episode. No, jokes aside, we have planned the feedback episode before this Christmas, I think, if I'm completely mistaken.
Yeah. Very good. Okay.
So over to the boxes, Martin, I suppose.
All right.
Before we wrap this up.
Yeah. Go for it.
Come on, what's your box?
My box is a series called Citadel.
Yes, I watched that. I really enjoyed it.
Yes.
The only tiny.
Well, there are some implementation details that are not quite that believable.
I mean, I found it very good, but it was. I think the initial season was only limited to eight episodes or something like this, right? So it wasn't that many episodes. But Martin, do explain what this is all about.
What's this all about? This is about an organization that is beyond all the official government ones that, pretty much looks after the safety of the world, right?
Yes. An FBI or CIA splinter group, but that's kind of...
Yeah. One that doesn't exist officially type of stuff.
Yes.
Yeah, that kind of idea.
Very good. I liked it. I think IMDb gives it, 7 stars easily or something like that?
Oh, I don't know. It was quite entertaining.
Yes. So I reckon you've watched the whole season.
Yeah, it didn't take very long indeed.
Okay.
But yourself, what's your box?
Yeah, my box is actually, for a change, some young people, I won't mention their names because they may or may not be listening, alerted me to the fact that there is actually...
Is this to do with your Irish adventure? No.
No, not
Okay.
at all, not at all, not at all.
That's for
Alerted me
another
to,
episode.
yeah,
Yes.
alerted me to the fact that actually there is something meaningful on Instagram
Oh
beyond
yeah. Oh,
beach
cats.
pics and cat videos and all the rest of it. Exactly. It's actually a Instagram account called Food for Thought Redux. It's pretty new, apparently. Links, of course, will be in the show notes. Whoever is behind this account publishes a picture a day with, indeed, a caption that is, depending on the
like
picture,
one of
really
those
food for
calendars.
thought.
Yes.
Yes, more or less, yes.
Yes,
Exactly,
I remember those. For the young people amongst us, we used to have calendars.
Exactly. Yes. And you could tear them off, yes, but now it's actually on Instagram, and it's really food for thought at some stage.
Okay. Do you have one for us?
I think today's picture was actually, and we're recording this on the, 27th of July, if I'm completely mistaken, was actually the belayed Sinead O'Connor, and the caption was, "May she be off to better places." Because at this point in time when we're recording this, it's still unclear why she died. And there's speculation out there that might suggest that this wasn't a natural cause of death.
Wow,
apparently she was quite troubled. Apparently she was quite troubled during her 56 years of life. If current coverage is anything to go by.
Okay.
Her son died about 2 or 3 years ago.
Yes, that's rather sad, of course. Yeah.
So indeed. So so that's the Instagram channel. And
Excellent.
with that,
yes,
we would like to thank you for listening. Exactly, and see you soon. This is the Linux In-Laws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
This podcast is licensed under the latest version of the Creative Commons license, type Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for their song Solid Market, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under CC at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.